Hi guys, welcome back to our new course on pandas. This is gonna be an introductory video. So let's get started. So pandas is a Python library used for working with datasets. It has functions for the following tasks. First of all, we have data analysis. So data analysis is the practice of working with data to glean useful information which can then be used to make informed decisions. So in data analysis, basically, we try to find out patterns from data. So we extract meaningful information and we use that information in future to make meaningful and informed decisions. The second is cleansing. Data cleansing or data cleaning is the process of detecting and correcting corrupt or inaccurate records from a record set, table, or a database, and it refers to identifying incomplete, incorrect, inaccurate, or irrelevant parts of the data and then replacing, modifying, or deleting the dirty or coarse data. So in cleansing, what we do is we correct the wrongly processed data. For example, when you are making a data set, there must be some values missing in a record that may not be available. So we just need to clean them. For example, we have a row with empty values. So we have to replace that row because we can't work with raw data. Data needs to be in a meaningful form to extract patterns from the data. And the last part is data exploration. It is very similar to initial data analysis, whereby a data analyst uses visual exploration to understand what is in a data set and then characteristics of data rather than through traditional data management systems. So in data analysis, we try to use the functions to find out patterns like the mean, the median, or something like that. But in data exploration, we draw colorful plots or charts to analyze the data. The process of analysis and exploration are usually performed together and together known as EDA or exploratory data analysis. So it includes the data exploration with the help of charts or plots as well as with the help of functions. So it is called as EDA or exploratory data analysis. Whenever we have any project, the first part is to perform the EDA or the exploratory data analysis and then cleaning. Because if we know what is the problem in data, then only we can clean the data. So these are three important functions that are facilitated through pandas or with the help of functions that are available in the module pandas of Python. Now let's move on to our next question. Why even use pandas? So pandas has a lot of other functionalities as well. We'll go through some of them. First one is analysis of big data. So what is big data? Big data refers to the datasets that are too large or complex to be dealt with by traditional data processing application software. The size of big data is very large and the computational power required is very high. So big data can't be analyzed on your systems with the help of traditional software. We need newer software to analyze big data. So pandas can help with analysis of big data as well. The second is pandas can clean messy data sets and make them readable and relevant. So already discussed, it can help in cleansing or cleaning of data. The third one is it has a lot of use in data science. As already discussed, data science is a branch of computer science where we study how to store, use and analyze data for deriving information from it. So pandas has a bigger role to play in the field of data science. So what is difference between data and information? Data refers to raw facts. So it's usually in unprocessed form, while information has proper context. It means that it is in a processed form and we can directly extract patterns from information. Now let's move on to our next topic, that is what else can pandas do? So what are some additional functionalities offered by pandas? So first one is calculation of correlation among different keys or columns of features. So what is correlation? In statistics, correlation or dependence is any statistical relationship, whether causal or not, between two random variables or bivariate data. So in simple word, it means that how will one variable will be affected when the other one is changed. The second one is calculation of average values from the dataset, calculation of the minimum and the maximum values of a column in a dataset, deletion of rows that are not relevant or contain null values. So this comes under data cleansing. The second and third points come under the data analysis. And correlation is a very important aspect because whenever we do feature engineering, we have to do correlation analysis to find out which features are correlated and what is the extent of correlation. And we neglect the features which have a direct correlation or a perfect correlation because it doesn't make sense, as the both the features are giving us the same information. So why bother to take multiple features if one feature is sufficient? So in today's lecture, we covered the basics of pandas and the basic functionalities of this module offered by Python. Hi guys, welcome back to our course on pandas. In our last lecture, I introduced you to the Python module pandas, and today I'm going to teach you how to get started with pandas. That is how to install, import and do some basic operations with pandas. So let's get started. So first of all, let's discuss the installation of pandas. So installation of pandas. So if you already have the pip package as well as the Python installed on your system, so generally we prefer to do all the installations with either the pip installer package or the conda. So either it's pip install pandas or conda install pandas. So if you have Python and pip package already installed, then installation of pandas is very easy. So you just need to write the command pip install pandas. So install it using the command that is pip install pandas. So now I'll run it. So it says requirement already satisfied because I've already installed, but it may take some time in your system because you would be running it in the command line. Also, the Anaconda package comes with the pre-installed pandas module. So if you're using Jupyter Notebook and you have the whole Anaconda package, then you don't need to install it explicitly. It comes already installed with Anaconda package. So if this fails in your command line, and if you are using some other IDE, you can use a distribution like Anaconda, Spider, etc. that comes pre-installed with pandas. Now let's import the pandas module. So we just need to write import. So just simply write import pandas. So we have imported pandas successfully, but most of the time we import our modules as an alias because we can't write a big word every time we are using some functions. So we just import with a shorter name or an alias. So import pandas as PD, and PD is the alias here. Now let's check the version. So how to check what version are you using, you just simply need to write print pd dot underscore underscore version underscore underscore. So it says 1.4.2. I'm using notebooks, so I don't need to write print explicitly. But if you're using some other IDE, then this will not work. You have to write print pd dots underscore underscore version underscore underscore as whole. If I just write pd dot version, it works here, but it won't work on any other IDE. It works for notebook environment only. Now we'll create a data frame. So data frame is a very important part of Pandas module because this is mostly used in projects. So data frame, we'll discuss it in later in detail, that what is a data frame and how it works, how to add rows or columns to a data frame, what is difference between data frame and a normal table. So right now I'm just creating a data frame. So let the name be my data set, and I'm using a dictionary to create a data frame. So there are a lot of methods to create a data frame. You can pass lists, numpy arrays, or dictionaries to create data frames. So I'm using a dictionary here. I have to give values as key value pairs. So my keys are cars and values, and my values are BMW, Skoda as one list and 1 and 2 as another list. Now I'll just write print my data set So I'm going to print this dictionary first, and then I'm going to create a data frame. So my var or any data frame name is equal to pd.dataframe. Please note that data frame is case sensitive. So first alphabet is capital. My caps lock has some problem. So it's pd.dataframe and pass the dictionary. So dictionary name is my dataset and shift enter to run. So it's giving an error because I've not added a comma in the elements. So now it will work. So this is our dictionary and this is our data frame. So you can see the difference. So in today's lecture, I taught you how to get started with pandas. Hi guys, welcome back to our course on pandas. In today's lecture, we are going to cover the series data type in pandas. So let's get started. So the first question is, what is a series? So we know that pandas is usually preferred for data analysis. So we know that pandas is primarily used for analysis of data. So pandas is a module which is primarily used for analysis of data, and it has two major data types. The first one being a pandas series and the other one being a data frame. So pandas supports two main data types. First one being series data type and the other one being data frame data type. Usually we use data frames because a table or any data is in form of rows and columns. But series is very important because data frame is nothing but a bunch of series clustered together. So now our original question is, what is a series? So we know that Pandas has two main data types, series and data frame. And what is a series? So series is nothing but like a column in a table. So Panda series is like a column in a table, and when you combine a lot of different columns, it becomes a table, and in this case a data frame. So Panda series is like a column in a table, and it is a one-dimensional array holding data of any type. So Panda series is just like a 1D array. But now you must be wondering, then what is the difference between a 1D array and a Panda series? We'll get on to that topic. First, let us see that which data types can be used to create a Panda series. So we can convert a Python list, a NumPy array, or a dictionary into a series. So first of all, we'll try to make a series from a Python list. So first of all, I'm going to import pandas as pd and import numpy as np. Now I'll not use anything from numpy, but maybe in between I may need to use it. So I'm importing numpy as well. And I've created a Python list, that is my list. Let me just create it in a new cell. Yeah, I've created a list, and now I need to create a series. So I'll write a is equal to pd dot series, and s is capital, and I need to pass my list. That is my list only. So data is equal to my list. Now I'll just print, and this is the Pandas series. Now, let me just create a series from a NumPy array. So first of all, I need to create a NumPy array, and I have already discussed how to create a NumPy array in the NumPy module. So you can refer that module if you don't know how to create a NumPy array. So now I'll just write the same syntax, and I just need to pass the NumPy array instead of list. I'll print it again, so I got the same result. Now we covered the topics of creating a series from a NumPy array as well as a Python list. So we covered these two topics. Now let's move on to the topic of creating a series from a dictionary or a Python dictionary. So you know that in dictionary we have the entries as key value pairs. But first we'll try to understand the difference between an array and a series. And then we'll proceed to create a series from a dictionary and understand the difference, that how it is different from creating a series from a list or a NumPy array. So first let's try to understand the difference between a series and an array. So in an array, we have numeric indexes. So to refer to the first element, we'll use the zeros index. To refer to the second element, we'll use the index 1. And in general, to refer to the k plus 1th element, we need to use the kth index. So a series doesn't necessarily have numeric indexes. It can have access labels, meaning that it can be indexed by a label instead of numeric values. So instead of 0, 1, 2, I can use alpha, beta, gamma, A, B, C, or anything I like, or any word like ABC for 10, XYZ for 20, DEF for 30. So a series can have access labels, meaning that it can be indexed by a label instead of numeric value. But by default, it has a numeric indexing. It means that if I don't pass a value for the labels, the default label will be a numeric value like 0, 1, 2, and so on. So now we'll create a series using a dictionary. So now I'll create a series using a dictionary and we'll see what is different here. So first of all, I need to create a dictionary. So let there be a dictionary with the name A, and it has element Anna, and let's add one more element after we give the values for this key. So let Anna has the value 10 and Jasper has the value 20 and Nikita has the value 30. So Anna, Jasper and Nikita are the keys, while 10, 20 and 30 are the values. So now I'll create a series. So W is equal to pd.series, and I'll pass this dictionary and I'll print it. So Anna, Jasper and Nikita here act as the labels for the series, and 20, 10, 20, 30 are the values. So in today's lecture, we covered the concept of pandas series. That will be all for today. Hi guys, welcome back to our course on pandas. Today we are going to continue our discussion on pandas series. So let's get started. In our last video, we covered how to create a pandas series from a list and an array, as well as what is the difference between a series and an array. So we'll continue our discussion on labels and indexing today. So now our task is to take the data and label values as separate lists and create a pandas series. In our last lecture, we used a dictionary for the values as well as the labels, because the keys can act as label values and the values can act as the entries. So now our task is to take the data and label values as separate lists and create a pandas series. So first of all, we are going to import pandas. So import pandas as pd and import numpy as np. Now we'll take two lists, one for the data and one for the label. So first of all, let's take labels as AB, comma, BC and CD. So we have defined the list for the labels. Now we have to define the list for the data. So let's data Z equal to, let it be numeric. So 1, 2, 3. Now we'll just write the series name or Q is equal to pd.series, and we'll pass two parameters here. First one being the data. So data is equal to data Z, and the second one being the index. So index is equal to labels. So in last case, we just passed a dictionary and automatically the index or the labels and data was assigned. But in this case, we have to pass data and index. So So here we can see that it doesn't have a numeric index. It has the index as the value of labels that we have passed. Now let's see what if we don't pass the index values. So it's not a brainer. If we don't pass index values, they will be taken as the default numeric values starting from zeros. So it will be 0, 1, 2 and so on. Now let me just print the capital Q. So it's 0, 1 and 2. So if you don't pass the index, it automatically will take numerical values or the numeric values. Now let's move on. Let me just give you an assignment. Now your assignment is to take a list and a numpy array as an input and create a series. Please do all the assignments. It's helpful and it will help you learn more. Now let's move on to using an index to access a particular value. So we'll use an index to access a value. Let me just access the value 2 here. So I can write capital Q. So to access the value 2 in capital Q first. So I'll just write capital Q of 1. I'll just run this cell and I got 2. And to access 2 from small q, I can write q and in bracket I have to specify the label, that is BC. So I got 2 as result. So in today's lecture, we continued our discussion on labels and indexing. Hi guys, welcome back to our course on pandas. In today's lecture, we are going to cover some operations on pandas series. So let's get started. So we are going to cover some basic operations such as sum and difference. So operations on series. First of all, let me declare or define 2 series so that I can perform operations on them. So let series 1 or ser1 is equal to pd.series, and let me just pass a list and labels. So I have to pass the labels as a list. So pd.series list and the list of labels as index. Similarly, I have to declare the second series. So let the elements be 2, 3, 4, 5 and the index be a little different this time. So let it be B, C, D and E. So the indexes are not same or the labels are not same. Let me just import pandas as PD. Don't forget to do this. Sometimes I do forget because I think that it's continuation of previous notebook, but I'm making a new notebook every time. So I have to declare it or import again. Now let's just perform the additions. So ser1 plus ser2. So I'll just run this cell and I got the sum. It shows not a number for label A and label E because there are no values corresponding to these labels in the other list. For example, label A is only in series 1 and there is no label A in series 2, so their sum is not a number. Similarly for the label E. Also, we can use the add method to perform the sum. So we can also use the add method to perform the sum or for addition. Now I'll demonstrate the use of add method. So I just have to write ser1 dot add and ser2 in the bracket. I'll run this cell. We'll get the same result. Now we should observe that whether it causes the change in series 1 or not. So I'll just print the series 1, ser1, so no change. So add method doesn't cause any change in the original series. It just performs the addition and returns a new series. So no change in series 1. Now let's see what's the difference between addition using add method and the normal add operator. So in this case, we can also pass the default fill value. So we observe that there was nothing corresponding to label A in series 2, but we can give a default value in this case. So the label A will be filled by 0 in series 2. So sum 1 plus 0 will give us 1 and not a number. So this is the difference. We can give the default fill value if there is no corresponding label in the other series. Similarly, we can perform the subtraction using the subtract operator or the minus operator, as well as using the sub method. So this is your assignment, that you have to perform subtraction using the minus operator and dot sub method and demonstrate the code and the output as well. So in today's lecture, we covered some basic operations related to Pandas series. Hi guys, welcome back to our course on Pandas. In our last lecture, we concluded our discussion on series, and today we are going to start data frames. So let's get started. So our first question is, what are data frames? So data frames are the workhouse of Pandas. So they are directly inspired by our programming language, and they're nothing but a bunch of series objects put together. So series is one dimension. We just cluster together a bunch of series and it becomes a data frame. So data frames are the workhouse of Pandas. They're directly inspired by the R programming language, and we can think of data frame as a bunch of series objects put together, because series is one dimension, and when you combine a group or a bunch of series, so it becomes a tabular structure, that is a data frame. Now let's see how to create a data frame. So first of all, we have to import NumPy and Pandas by alias. So import NumPy as NP and import Pandas as PD. Now we'll run the cell. Also, in this case, I'm going to use the rand-n method of NumPy to create a 2D array, which I will pass to data frame. So I'll import that also from numpy.random import rand-n. I'll create a data frame with the name df. So df is equal to pd.dataframe, and in this case we have to pass a 2D array. So instead of passing a whole 2D array, I'll just write rand-n 5, 4, because this will return me a 2D array, and I have to pass a list of index as well as a list of columns, because a data frame has indexes as well as column values or keys. So I'll just write A, B, C, D, E dot split, because this will return me a list. I can either write split and I can pass comma, or I can just give normal spaces. So A, B, C, D, E, and by default the split is along the blank or the white space. Similarly, for the columns, I'll pass W, X, Y, Z and dot split, because this will also return me a list of 4 elements, and 4 into 5 is 20, which is the dimension of the data frame. So this is the resultant data frame. Now I'll try to access a row directly. To access a row or an index in a series, I can write df and in bracket pass the index or the label. So dfa, this will work when I use it in a series, but will it work in a data frame? Let's check. So df of a, where a is the label, this is giving me an error. So this helps us to deduce the fact that we can't directly access a row using a label in case of a data frame. So this gives us an error. We'll discuss the use of .loc and .iloc later for selecting rows of a data frame. So we'll discuss these topics in upcoming videos. But there is one more point here. We can't access the rows directly, but we can select the columns directly. So df of x, where x is the column label, will give me the column values. So I'll just write df of x, where x is the column label, and it returns me a series, because data frame is nothing but a bunch of series put together. Now let's select multiple columns. To select multiple columns, we have to pass a list of columns. So you need to pass a list of columns. So x comma y or y comma z or anything. So there's an error in syntax. Let me just rectify it and then I'll run. So this is the correct syntax and this is the result. Please note that you have to pass a list of column labels and not just labels separated by commas. Now let's prove that data frame is just a bunch of series objects. So to prove that data frame is just a bunch of series, you can use the type method and select a column. So if you can prove that every column of a data frame is a series, then it's proven that data frame is just a bunch of series objects combined. So I'll just write type and in bracket I'll pass df and I'll pass df's w column. So it gives me pandas.core.series.series. So it's a series object. So in today's lecture, I introduced you to the data frame data type of pandas. Hi guys, welcome back to our course on pandas. Today we'll continue our discussion on data frames and I'll teach you how to add a column to a data frame or how to remove a column from a data frame. So let's get started. So our topic is adding and removing columns. Adding and removing columns to / from a data frame. So first of all, we are going to create a data frame. So our first step is to create a data frame. So I'll first do the necessary imports. So import pandas as pd, import numpy as np, and from numpy.random. I need to do one more import before I can create a data frame. Let me just write the instruction for the data frame first, then I'll add that command. So df is equal to pd.dataframe rand n 4, 4. We'll create a matrix of dimension 4 cross 4 and we'll pass it to the data frame. Along with, we have to pass the index. So we'll pass abcd.split. It will return a list containing 4 values, and similarly we'll pass the columns w, x, y, z. And also we'll add dot split because it will also return a list containing 4 values. Now I'll run it, but I have to do the necessary import first. So from numpy dot random import rand n, because rand n requires this import. Or you can use numpy.random.rand n instead of only rand n. So it will also work. So now it's giving an error because the word columns is not spelled correctly. So let me just change it. Yeah, now I have created a data frame successfully. Now just print it. So this is our 4 cross 4 data frame. Now I'll try to add a new column to the data frame with the name zn. So df of zn, or df bracket or square bracket, and the column name or the name of the new column is equal to, then I have to pass the values because every column has 4 values. I have to pass 4 values. Now let's display the modified data frame. So here we can see that a new column has been added successfully. Initially we had w, x, y, z. Now we have w, x, y, z and zn. So we have added a new column successfully. Now let's remove the column. So generally we use a method known as drop to remove a column. So I'll write df.drop and I'll pass the column name and also the axis, because whenever we deal with columns, we are dealing with axis equal to 1. If you don't pass this axis equal to 1, it will give you an error. So this is the modified data frame when zn has been removed, but it will not make changes in the original data frame. It just returns a new data frame. So is it actually deleted? No, it's not. When you display df, you still have zn. So it's false in place by default. What is in place? Let me illustrate. In place true or in place false while performing any operation means that do you want to make changes to the original data frame or not. If in place is false, then no changes are made to the initial data frame. And whenever you want to make changes, you have to pass in place is equal to true. Now when I'll make this change, it will remove it permanently. It's giving an error because the name is zn, not ze. Yeah. Now it has been removed permanently. So when you specify in place is equal to true, it makes changes to the initial data frame only. So in today's lecture, we covered how to create new columns and how to delete columns from a data frame. Hi guys, welcome back to our course on pandas. In today's lecture, we are going to continue our discussion on data frames and I'll teach you how to select rows of a data frame. So let's get started. So today's topic is selection of rows of a data frame. So this is the topic. First, let me just import. So import pandas as pd, import numpy as np, and from numpy.random. So from numpy.random, import rand. We are using this to create an array, a 2D array. You can directly pass a 2D array, but that will just make the code a little bit complicated. Not complicated, but it won't look very clean. So that's why we are creating a 2D array with the help of rand method. So let me just create a data frame and I have to pass index value as well as the column values. So let the index be A and B and the column be C and D. So I have to pass these as lists and I have a 2x2 matrix that will create a 2x2 data frame with the index A, B and column values C and D. So I have created a data frame. So this is our result in data frame. Now let's just try to select a column first. So we have selected the column C. So we can conclude that we can select a column directly from a data frame. Now let's try to select a row. Let it be A. So df of A. So this is giving us an error. So we can conclude that we'll get an error while trying to select a row directly. So error while trying to select a row directly. Also, all the necessary notebook links will be given this time, so you can just refer to the notebooks if you are not able to implement something. I'll share a GitHub link. So selecting of rows is therefore different from selection of columns or from selecting columns. So selection of rows and selection of columns are done by different methods, and selection of rows can be done using two methods. First one is .loc method, and in this we have to pass the label. So .loc, and we have to pass the label, or label is passed, and the other method is iloc method, and in this case index is passed. So there are two methods for selection of rows. First method is .loc and the other method is .iloc. In the first one, label is passed, and in the second one, index is passed. Let me just write df.loc A. So here we can directly pass the label and we'll get the row. And in iloc method, we have to pass the index. So the index of A is 0. So it gives us the first row. Similarly, we can select the second row using LOC B or using ILOC 1. Now let's see how to select a single cell, because we have selected rows, we have selected columns, but now we want to select a single cell. So I can write df dot loc and I have to pass a comma c. So it selects the first row and the first column or the first cell. Now let's select the value .424. So what is the code that you are going to write to select this particular cell? So it is the second row and the second column, or the column D and the row B. So df b comma D, but we have to write df dot loc because we are passing the labels, so we have to write loc. Or we can write df dot iloc 1 comma 1. So it is the first index column wise as well as row wise, because 0 and 1 and 0 and 1. So first. Now let's select subset of a data frame. So in this case, we are going to select the rows A and B, but only one of the columns. So I'll write df dot loc and I'll pass both the rows and only one column. Oh, it gives me an error because the mixing is not allowed. You can't mix. If you are using .loc, then you have to use all the labels only. You can't use indexes. Now let's try using this. This also gives us an error because if you are passing a single element, you don't need to pass it as a list. Also, it won't work if you pass two of the elements as list in both the cases. So this is the wrong syntax. Also, if you do mixing of any kind, that is also wrong. So this also gives an error. Now let's see what happens if I pass both the row values instead of a row and a column value. So there was an error, but now I passed a row value and a column value, so it's correct. Also, now I'm going to pass a list as the row value and only one column value. So this is the result. So that's the correct method. Also note that mixing of labels and indexes is not allowed or not supported. So in today's lecture, we covered selection of rows of a data frame. Hi guys, welcome back to our course on pandas. In today's lecture, we are going to continue and hopefully conclude our discussion on data frames. And today we'll discuss conditional selection in data frames. So let's get started. So the topic for today is conditional selection. So conditional selection is an important feature of pandas in which we select cells or sub data frames or subsets of data frames or rows or columns using bracket notations in a way which is very similar to NumPy. So the use of bracket notation is very important. Also, we know that a conditional operator always returns a true or a false value because every condition that we are checking is either true or false. So it makes sense that a conditional operator or any conditional operator returns a true or a false value. Now let's demonstrate these concepts using code. First of all, let me just import all the necessary modules or functions. So from numpy.random import randn. We are using randn for creating a 2D array and then passing it to create a data frame. So let's first create a data frame and then I'll demonstrate the concept of conditional selection. So we are writing this statement to create a data frame. Let it be 3x3 data frame. So I have to write rand in 3x3 or 3, because we don't write cross here. We write 3, and I'm going to pass the index values as, let it be a, b, c. So the index values are a, b, c, and we have to pass this as a list, or I can also write a, b, c with space dot split because that also returns a list, or I can write directly and let the column values be D, E and F. Now I've created a data frame. So this is our data frame as visible on the screen. Now what if we want to select under a given condition? So df greater than 1, and let's execute the statement. So it gives us true and false values. So all the values which are greater than 1 corresponding to those we get true, otherwise we get false. Now what if we want the values which are greater than 1 and not just true or false? We actually want to print the values. So we'll write df and in square bracket, not in this round bracket, in square bracket, we'll write df and df greater than 1. So it will print the value which is greater than 1. So that is 1.24 and so on. And it will return not a number for all the other entries. Now what if we want to check a particular column only? So we'll write df and we'll write in square bracket df of d greater than 0. So all the rows in which the value of column D is greater than 0 will be displayed. That's all the rows. So we don't see any difference. Now let's change it to 1. So now only first row is displayed because only in first row the value of column D is greater than 1. That is 1.24. Now what if we want a particular cell? Or I should not frame it like this. I should frame it like to select particular rows and particular columns. So it can be a cell or it can be a subset of the data frame. So we'll write df of d greater than 1 and A. So it is giving me an error because I have to pass a column value. So in this case, we got the result. So it is framed like this. What if we want to a particular column? So we are selecting a particular column and a particular row, or a set of columns and rows. So it's either a cell or a sub data frame. So there's a little ambiguity here. So please take care of that. So in today's lecture, we covered conditional selection in data frames. So we conclude the topic of data frames. Hi guys, welcome back to our course on NumPy. In our last lecture, we concluded our discussion on data frames, and in today's lecture, we are going to see how to read and view data using the functions offered by the Pandas module of Python. So let's get started. So today's topic is reading and viewing data from CSV and JSON files. So these are two important or the two major file formats in which data is available. So we have two data sets here. First is the iris data set and the JSON version. We'll download the two versions of the iris dataset. The first is the JSON version and the second is the CSV version. So let me make sure that it is in the same directory as our notebook is going to be. Otherwise, it will give us an error when we'll try to read data from these files. So it is iris.csv and iris.json. This data set is publicly available and both the versions can be downloaded from Kaggle. Now let's move back to our notebook, that is reading and viewing data from CSV and JSON files. So first we are going to import pandas as PD, and now we'll create a data frame. So df is equal to pd.read CSV. Please note that read CSV is a function which is used to read CSV files and extract data frames from the CSV files. Now we'll just print the data frame. So it gives us the first 5 entries and the last 5 entries. Let me just write df and execute it so it's in a better format. So it contains 150 rows and 6 columns. But what if we want to display all the rows, like all 150 rows I want to display? Then I'll convert it to string using the toString method. So I'll write df.to_string function. So it will give me the whole data set. So this is the data set and all the 150 entries have been displayed. Now let me just print the first 5 entries of the data set. So I'll write df.head. So head method here displays the first 5 entries. Similarly, the tail method displays the last 5 entries by default, and this can be changed by passing the parameters. So it displays the last 5 entries of the data frame. Now we can have some basic info by using the info method. So it tells us about the columns of the dataset and the non-null count in the column. So all the 150 entries in the dataset are not null when we check every column. So this dataset is probably clean. Also note that the names of all the columns can be extracted using the keys method. So we'll write df.keys and we'll execute. So we got all the column names as a list. Now, as already discussed, we can pass arguments to the head and the tail function. We want to change the number of entries. So here, if I want to display the first 15 entries, I have to pass 15 in the head. Similarly, if I want to display the last 15 entries, I have to write df.tail and in bracket I have to pass 15. So I've displayed the first 15 as well as the last 15 entries. Now let's see how to read JSON files. So for that, we have a function called as read JSON. So I'll write pd.read JSON. So I have to write pd.read JSON and I have to pass the file name. So it is iris.json. So iris.json. So this is the same dataset, just the format is different. Also note that JSON files are generally used to deal with big data. All the other functions will remain same, like the head, tail, info, everything. Everything will remain just the same. Just note that the format is different. So the function to read will be different, but the dataset will be dealt with the same functions. So in today's lecture, we covered how to read and view data from CSV and JSON. Hi guys, welcome back to our course on pandas. In today's lecture, we are going to do correlation analysis using the function offered by pandas module of Python. So let's get started. So as already discussed in the introductory lecture, in statistics, correlation or dependence is any statistical relationship, whether causal or not, between two random variables or bivariate data. So in simpler words, it tells us how two different columns or different features or different keys in a data frame or a data set are related to each other. So correlation, in simpler words, is used to find relationship among the features or among the columns or among the keys. So this is more of a formal definition. Correlation or dependence is any statistical relationship, whether causal or not, between two random variables or bivariate data. And in simpler words, we can say that correlation is used to find relationship among the features. Now, a great aspect of the pandas module is the core method or the correlation method. In short, we say core or core or anything. It doesn't matter until you write the correct thing when you are coding. So a great aspect of pandas module is the core method. So it can calculate the correlation between each column of the dataset. So the core method calculates the relationship between each column of the dataset. Now I'll demonstrate the use of core method. So first of all, let me just do the necessary import. So import pandas as PD. Now I'm going to extract a data frame from a CSV file. So pd.read CSV and let the file name be iris.csv. This is the same file that we discussed in our previous lecture. Now I just need to write df.core and it will return me a new table, or we can say a data frame with the correlation values. You can read more about the correlation analysis in statistics, but let me just tell you in brief how to read this table. So the core method ignores the column which are not numeric. So it had 6 columns, I think. One was about the species, so it was not included in this table because the core method ignores the column which are not numeric. And the result of core method is a table consisting of numeric values. Also, if you observe carefully, you'll notice that all the values in this table vary between -1 and +1. So the negative or the minus values denote a negative correlation. So if one variable increases, the other one will decrease. So this is the meaning of the negative correlation. And the positive values or plus denotes a positive correlation. It means that if one variable will increase, the other will increase as well. Now, our next question is, what is a good correlation? So when we have a numeric value of 0.6 or -0.6, that denotes a good correlation, either positive or negative. Like positive 0.6 will denote that it has a good positive correlation, and a negative value will indicate that it has a good negative correlation. Another important thing to note is the presence of a perfect correlation. So if you are having a correlation value of +1, it denotes a perfect correlation. And note that every feature is perfectly correlated to itself. For example, petal length is perfectly correlated to petal length. It's not important that to have a perfect correlation, we observe the correlation in same features. We can have perfect correlation in different features as well. But if the features are same, then they must be perfectly correlated. Now let's see the correlation in form of a heat map. We'll discuss more about heat maps and other plots in the matplotlib and Seaborn module. I'm going to give you a brief intro only. So we are going to observe this correlation in form of a heat map. For that, I need to import Seaborn as SNS and matplotlib.pyplot as PLT. Also note that if you don't have these modules installed in your system, you can just skip, because I'm going to teach this in future playlists as well. I'll write sns.heatmap and I'll pass the table or the data frame, that is df.core. So I'll write df.core. So it gives me a heat map. Note that light value means a positive correlation and darker color means a negative correlation. Let me just print the correlation values as well and change this color combination too much of something cool warm, and not is equal to true. Now I have the correlation values as well as a different color for better visibility. So today's lecture was all about correlation analysis using pandas. Also, we'll discuss more about plotting in future playlists. Hi guys, welcome back to our course on pandas. In today's lecture, I'm going to introduce you to the concept of data cleaning in pandas. It is one of the most important stages in data pre-processing. So let's get started. So today's topic is data cleansing, or more popularly known as data cleaning. So data cleaning means fixing bad data in our data sets, and bad data could be of many types. So we'll discuss what can and cannot be considered as bad data. So you have a clearer picture in your mind that what comprises of bad data. So bad data could be data in wrong format, empty cells. Let me just make a new cell for all this. Just wait a second. So bad data could be data in wrong format, empty cells, wrong data, duplicates, that you have the same entries many times. So all this comprises of bad data, and we need to clean, or we need to remove this kind of data from the data set or data frame. So first of all, we'll discuss how to deal with empty cells. So first of all, let me just import pandas as PD. So I'm going to import pandas as PD, and I'll read the data frame. So df is equal to read CSV, and I'll pass iris.csv. Now let me just, sorry, it's pd.read. So let me just display the first 5 entries of the data set. So you can see that data is already clean. So I need to add some other columns so that it is not clean anymore, and then I'll demonstrate how can we actually fix the data set. So let it be df of additional data is equal to not a number. Oh, this gives me an error because NaN can't directly be used with Python. So there's a numpy function for it. We'll discuss it later. For now, let it be none. So I'll change it to none. Just give me 1 second. Yeah, so let me just change it to none. So it's still the same data set, but we have added an additional column that is none. So all the entries are none. So you can observe that this columns makes absolutely no sense if it were present or not. So this is kind of an example of bad cells. Now this column contains only none values. So the right choice would be to remove this entire column which has none values. Now there's also a method to remove the rows that contain not a number values or null values. So there's a little ambiguity here. There's difference between none and not a number or NaN here. So new df is equal to df dot drop na. This will remove all the rows containing none values. So the new data frame is empty because every row contains a none or a NN value. So it will remove all the rows because of that column. So this method is not a perfect choice here. We should remove the column itself other than removing all the rows containing none or NN values. So if I display the head of the new data frame, it is also empty. So hi guys, welcome back to our course on pandas. In our last lecture, we started the topic data cleaning and I demonstrated how to remove a column and how to remove rows with none or not a number values. Today we'll see how to replace the null values with the mean or median and other simple methods of data cleaning. So let's get started. So this is continuation of the previous video. I'm just gonna make this data a little more dirty by adding an additional column which has empty values. Now I'm gonna replace the empty values by a number. So this is one of the methods of data cleaning. So replace the empty values by a number. So we'll write df.fill na and we'll just provide that number by which we want to fill the none values. This is to be used if all the rows have a value in common, like they have 1, 2, 3 in common, or we are adding a city for a particular set of people who live in same city. So all people will have the city value as same. So this is to be used only when all the rows share a same value. Now I'm going to add 2 more columns in which the values are none so that I can demonstrate a few more concepts of data cleaning. Now you must have observed that we filled additional data column with value 1, 2, 3, but when I displayed the data set again, the changes were not committed. So to commit the changes, we always need to specify in place as true. So I'll write fill na or fill the none or the null values or the NaN values in the column A, add 1 and in place is true, so that when I display the data set again, the changes have been committed. Now I'll just drop one of the columns because I have a lot of columns with none value that I may not require. So one of the simple method as illustrated before is to just drop the column. So this is a very long and documented error, and there is an error because I have forgot to mention the access. Always remember that when you are dropping a column, you have to pass the access equal to 1 and then you have to execute it. So now I'll just run this cell again. So I'll run this cell again and it works perfectly now. So I'll display the data set again. So the empty column add with no values has been removed. Now I'll teach you how to replace the rows which have none values with the mean of other values in that column. Because the rows have null values. Some of the rows might have null or none or any values for a column. In our case, the column is absolutely empty. So let me just fill some of the values in a column, and then I'll tell you how to fill all the other values in the column using mean, median, etc. So let me just change the column values. For some of the rows. So you can see that I have replaced one value of this column, additional data, with 3. And I have also accidentally changed the value of another column to 4, but it won't matter. Let me just correct it and select the right column. Yeah, now I have replaced 2 of the values by 3 and 4. Now I'll replace all the other none or null or not a number values in this column with the mean of these two values. So x is equal to df additional mean or additional data dot mean. So x is the mean here, and I'll write df, and the column name is additional data, and I'll write fill dot fill na, and I'll pass x, which is the mean, in place is equal to true. Now I'll display the data frame. So all the other values have been replaced with mean of these values. Now I've left with just one column which has all the none values. Let me just drop it simply. So I'll write df.drop and pass the column name. X is equal to 1 and in place is equal to true. Now the data is clean again. Also, I'll demonstrate some of other ways to handle null data in a specific lecture which will be dedicated to handling of null values. So in today's lecture, we conclude our discussion on data cleaning. Hi guys, welcome back to our course on pandas. In today's lecture, I'm going to teach you how to visualize data using inbuilt functions of pandas. So let's get started. So I'm going to cover the use of plot method to draw plots using pandas. So the title is Pandas for Plotting, and an idea only. I'm not going to discuss it in detail. I'm just giving you an idea. So pandas uses the plot method to create plots. Also, to visualize the plots, we can use pyplot, which is a submodule of the matplot library. So I'm using notebook, so I don't need to use this pyplot, or I don't need to import the pyplot. But if you're using some other IDE, it is vital, it's important, it's absolutely compulsory, otherwise you won't be able to visualize the plots. So first of all, I am going to import pandas as PD, and I will also import matplotlib.pyplot as PLT. So our first job now is to read the CSV file and extract the data frame or the dataset from the CSV file. I'll use the same iris dataset. So I'll write pd.read CSV and I'll pass the name iris.csv. Now I'll display some entries. So this is our dataset or our data frame. Now let me just draw a scatter plot. We'll discuss two plots. First is a scatter plot and the other one is the histogram. So df.plot kind is equal to scatter, and I have to pass the x and y values because in a scatter plot we plot points and we have to pass the x coordinate as well as the y coordinate. So let the x coordinate be petal length in centimeter and the y coordinate be sepal length in centimeter. So scatter plot can also be used for correlation analysis. So we can see that how petal length and sepal length are correlated using a scatter plot. So it is also important. So see, as petal length increases after 3, the sepal length also increases. There is some correlation, although it is not a very good correlation because for the values from 1 and 2, the plot is kind of messy, but after 3 it shows a positive correlation, although it doesn't seem a very good correlation. We are using notebooks, so we don't need to write plt.show, but it will be required if you use some other IDE for executing this code. Now let's move on to our next plot. So let's draw a histogram now. So histogram is kind of a frequency plot. So we have a variable and its frequency. So let the variable be sepal length in centimeters and the y-axis will give the frequency of that particular sepal length, that how many flowers have that particular length of sepals. So I'll write sepal length centimeters and I'll write dot plot kind is equal to hist or histogram. So this is our histogram. So in today's lecture, we covered how to draw plots using pandas and the data visualization abilities of pandas. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates. And stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, I'm going to discuss the merging of data frames in pandas. So let's get started. So the merge function is used for merging of datasets in pandas, or we can say that the merge function facilitates the merging of datasets. So there are three terms here: merging, joining, and concatenating. So we'll also try to understand the difference between these three. So the first is merging, and it is done by the merge function. So the function merge allows us to merge data frames together using similar logic as merging SQL tables together. So this merging is same as joins in SQL, if you can recall. The inner join, outer join, left join, right join. that is same as this merging. So the merge function allows us to merge data frames together using a similar logic as merging the SQL tables together. If you haven't studied joining in SQL, I request you to find some good video on SQL joins and go through it. Now I'll create a data frame. In this case, I'm going to create two data frames, left and right. Then I'm going to demonstrate inner join or the inner merge, outer merge, same as SQL joins, inner, outer, left and right. Let me just create two data frames real quick. This gave me an error because I forgot to import pandas as PD. So this is our left data frame or the data frame 1. In a similar manner, let's create the second data frame. We just change some values in the original data frame and that's it. So create two data frames first and then try to perform different types of merging. And merging is similar as SQL joins. So there are generally 4 kinds of merging. And also note that for merging, we require keys. That is very important. So this is our right data set and we have one more data set that is left. So these are the two data sets. Now I'll write pd.merge and I'll pass both the data sets, that is left and right, and I'll pass on equal to key 1 comma key 2. So merging is performed on keys. That is very important. So this is the inner merging or inner SQL join. So please take care of this. That merging is same as SQL joins and is performed on keys. So this is the inner join. If we want to perform the outer join, then we have to specify how is equal to outer. And we have to also specify on key 1 comma key 2. So that was inner join and this is outer join. Similarly, to perform right and left join, we just need to specify how is equal to left or right. So in a similar manner, we can perform left and right join. Also, for more information, please refer SQL joins. So in today's lecture, we covered merging of data sets in pandas. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. Today I'm going to discuss the joining of data sets or data frames with the help of functions offered by pandas. So let's get started. So the topic for today is joining. So joining is a convenient method for combining the columns of two potentially differently indexed data frames into a single result data frame. So we have two different data frames and we are combining the columns of two data frames which have different indexes and we get one data frame as a result. So this is the official definition. Now let's try to understand the difference between joining and merging. So joining is performed on indexes and merging is performed on keys. So this is one and only major difference between joining and merging of datasets or data frames in pandas. We are concerned with indexes. So now I'll demonstrate how joining works. But let me just complete this statement. So joining is same as merging but performed on indexes instead of keys K1 and K2. So the keys of the dictionary are A and B, and A contains the value as a list A0, A1 and E2, and the key B contains the value in a list B0, P1 and B2, and the index contains a list K0, K1 and K2. So in a similar manner, we'll create a second data frame whose name is right, and we'll make some changes in the columns as well as the index. Also, I forgot to import pandas as PD, so I got an error, but I've corrected it. So this is our left data frame, and in a similar manner, I'll create the second data frame. So let me just copy and paste whole thing, and I'll change the name, and I also change the key values as well. So it's C, C0, C1 and C2, or C0, C2, C3, or whatever you want to have. It doesn't actually matter. So the keys in this case are C and D, containing lists as C0, C2, C3 and D0, D2, D3, and the index values contain K0, K2 and K3. Now pay attention that joining is done on indexes rather than keys. So now I'll write left dot join and I'll pass right. So this is the inner join. Similarly, we can exhibit the outer join. I'll just need to write left dot join and I'll pass right, and I'll pass how is equal to outer. So this is the result of the outer join. In a similar manner, we can perform left and right join. So this is the result of left join and the result of right join. So in today's lecture, we discussed joining of data frame in pandas. That's all about joining. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. Today I'm going to cover the concatenation of data frames in pandas. So let's get started. So the topic for today is concatenation. So concatenation basically means gluing together data frames. Also note that dimensions should match along the axis we are concatenating on. So it is different from joining. What we are basically doing is we are just gluing two data frames together. And please take care of dimensions while concatenating. So let me just complete this sentence. Dimensions should match along the axis we are concatenating on. Also, to perform concatenation, we have a special method known as concat. So the use of concat method is done for concatenation. So use the pd.concat method and pass the list of data frames you want to concatenate. So let me just create a data frame real quick, and I also need to do the necessary import, that is pandas. But let me just first define the first data frame. So let me move on. So by mistake I went back. Now I have to do it all over again. So let me just do it again quickly. So I have to import pandas as pd, and I'll run this cell again and this cell again. So now I'll just display the first data frame, and in a similar manner I'll create the second data frame. So df2 this time, and the columns will remain the same. So the columns will be the same, A, B, C and D, but the indexes will vary. So the indexes should be in continuation here when I am concatenate along the axis 0. The only thing that we need to keep in mind while concatenation is the indexes and the values. If you don't have access to values or indexes, so the result of concatenation can be a little messy when you concatenate along the higher axis. But we are concatenating on axis 0 right now. So for the first data frame, the indexes are 0, 1, 2 and 3, and for the second data frame I'll specify the indexes as 4, 5, 6 and 7. So I'll make the necessary changes. Let me make some changes in the data as well. The data can be redundant also, but to make it look better, I'm just making some changes in data as well. But we can have redundant data. We just need to change the indexes. So let the indexes be 4, 5, 6 and 7. Now I'll just run this cell and I'll display the second data frame, that is in continuation of the first data frame. Now I'll write pd.concat and I'll pass both the data frames. So this gave me an error, because always remember that you have to pass the data frames in form of a list. So please don't forget indentation or the documentation, because different methods or functions take different kind of references or arguments. So make sure to pass a list of data frame. Now let's concatenate along the axis 1. So in this case we have to specify axis is equal to 1. Rest of the procedure is same. So I'll write pd.concat and I'll pass the list of data frames, as well as I'll specify the axis is equal to 1. So we have concatenated along the columns or along the axis 1. So we have concatenated along the columns. Also note that we got a lot of null or NaN values. So make sure you have all the necessary values for concatenation if you're doing concatenation along the axis 1. So make sure you have all the values for concatenation, otherwise it will give nan or null in the results. So in today's lecture, we covered the concatenation of data frames in pandas. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, I'm going to teach you how to combine multiple conditions using selection and how to extract information about unique elements from a data frame. So let's get started. So today's topic is selection and information on unique elements. First of all, our job is to create a data frame. So create a data frame first. So I'm going to import pandas as PD and I'll create a data frame. So df is equal to pd dot data frame. So in this case, I'm not going to use the randn method. I'm just simply passing the column wise values in form of a dictionary. So in a similar manner, you have to create a data frame. With 3 columns. So this is our third column and execute it. So we have created a data frame and this is the resultant data frame. Now under selection, so we select from data frame using criteria from multiple columns. So we'll combine multiple conditions using operators such as and or. So we can select from a data frame using criteria from multiple columns. So basically here we are combining multiple conditions using AND operator. So I'll write new data frame is equal to data frame and in bracket I'll specify the condition 1. So df column 1 greater than 2 and the other condition. So I'll write and df column 2 equal to 444 or 444. I'll execute this. Now I'll display. So it is giving me an empty data frame. Yeah, this is because our initial data frame should have 3 columns. So there's something wrong in our declaration of a data frame. So let's check, because it should have 3 columns. Here we have 2 columns. Oh, I have not given the correct name to the third column. So let it be column 3. Now let's execute. execute this again. Now we have 3 columns. Now this condition will work. So we have a row here. So this row had column 2 equal to 444 and the column 1 was greater than 2. So this is similar to the conditional selection we discussed earlier. Only difference is we are combining several conditions. Now we'll see how to get information on unique values in a column. So first we'll try to identify all the unique elements of a column and obtain them in form of a list. So for that purpose, we have to use the unique method. So I'll write df and the target column dot unique. So column 2 has 3 unique values, 444, 555 and 666. In a similar manner, we can calculate the count of unique elements of a column. So for that, I have to write df target column dot n unique. And I'll execute it. So it has 3 unique elements. First one gives us the unique element and the second one gives us the count of the unique elements or the total number of unique elements. Now our next objective is to calculate how many times the unique values appear in a column. So what is frequency of each unique value? So for that we have a method called as value counts. So here 444 occurred 2 times, 555 occurred 1 time and 666 occurred only 1 time. So in today's lecture we covered unique elements and conditional selection. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, I'm going to demonstrate the use of apply method of pandas. So let's get started. So the apply method is used for applying functions on columns. So we can select a particular column, apply a function on all the values of that column and store the result somewhere else, like in a new column or in a new list somewhere. So apply method is used to broadcast a function to the columns. That is, every value of that particular column will be treated with the function that is passed in the apply method. So first of all, let us read a data frame. So let's read a data frame first. Then I'm going to import pandas as PD. So now I'll write df is equal to PD dot read CSV and I'll pass the file name that is iris.csv. I'll display some of the rows of the data frame. So this is basically our data frame. Now let's create a new column that stores the length of species name. So the last column is the species and we have to count the number of characters in the species name for every row. So create a new column that stores the length of species name. So the procedure is very simple. We have to create a new column. So df of new column name or anything. Let it be len species or len species name is equal to df of species, because we are applying this function on the column species and we are applying the function that is length. So this needs not to be in commas, so I'm removing. So dot apply length. Now I'll display the data frame and it has a new column that is length of species name, and you can count it manually also. It's 1 2 3 4 5 6 7 8 9 10 11, and for the last row it is 14. Now let's create a function that takes a number and returns the number multiplied by 2. So create a function that takes a number and returns the number multiplied by 2. And our second job is that using apply method. So using apply method, create a new column that contains the doubled sepal length. So we have to create a function that takes a number and returns the number multiplied by 2, and we have to apply it to the column that is sepal length centimeter. So I'm creating a function first. So this is the function. Let its name be times 2 and it returns number multiplied by 2. Now df of sepal length 2 or sepal length doubled is equal to df sepal length centimeter dot apply times 2. I'll execute it, and now we have a new version of the data frame containing an additional column that contains the double sepal length. So apply method can be used to broadcast inbuilt or user defined functions. So it can be used to broadcast inbuilt functions as well and user defined functions as well. Also, we can use a combination of apply method as well as the lambda function. So today's lecture was all about the application of apply method in pandas. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, we'll discuss some methods, functions or operations of pandas to get information about data frames. So let's get started. So our topic is basic operations or functions. So we'll discuss some methods or functions of pandas to get information about the data frames. And these functions are very useful during data analysis. So use of methods / functions of pandas to get info about data frames. So I'll import pandas as PD. Then I'll read a data frame from the iris file as usual. So df is equal to pd.read_csv and I'll pass iris.csv. And this is our data frame. Now I'll just get some basic info about this data frame using df.info. So this is the application of info method or function. So it gives us the information about the column names, the number of null values and their count. So this we have already discussed in a previous lecture. Now let's move on. So how to get the names of all the keys of a data frame? For that we can write df.keys and it will display a list of all the keys. Moving on to the description, we can write df.describe. So it will tell us the count, the mean, the standard deviation, the minimum and the maximum value and the quartile distribution of each and every column, provided that it is a numeric column. Like for the species, it's showing nothing, so that is missing here. So df.describe can give us the description of each and every column. Another method to fetch all the keys is using df.columns. So it also returns us a list of all the column names. It is similar to df.keys. So this is same as df.keys function. Now we also have a function to fetch all the indexes. So it will not return a list of indexes, but rather it returns the start value, the stop value and the step size. In today's lecture, we covered some functions to get information on data frames. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, we are going to cover the topics of sorting and ordering using pandas. So let's get started. So our topic for today is sorting and ordering. So sorting and ordering. First, I'm going to import pandas as PD. So import pandas as PD. Our next job is to read a CSV file and extract the dataset from the file. So read a CSV file and extract a data frame. For that, I'm going to write df or the variable or anything is equal to pd.read_csv and the name of the file is iris.csv. So this is our data frame. So let's sort in ascending order by sepal length. So sorting in ascending order by sepal. So here we have sorting as well as ordering. So order is ascending and the variable is sepal length. So now I'm going to write df dot sort underscore values function, and it takes a parameters that is by, in which we have to specify the column name. So we want to sort by sepal length, so I'll pass sepal length centimeter, and it will return me the sorted data frame. Also note that it does not cause any change in the original data frame. See, there's no change in the original data frame. So we can say that by default, sorting is not in place. So in place is false by default. If we want permanent changes, we have to specify the in place as true. Now let's sort by petal length. So the syntax will be same. Df dot sort values by is equal to petal length centimeter. So this is quite easy to do. So let's sort by petal length now and write df dot sort values, and by is equal to petal length centimeters. And I'll run it. So this also returns a data frame but does not cause any change in the original data frame until and unless we specify the in place as true. So that's all about sorting and ordering the values or the entries in a data frame. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, I am going to demonstrate the use of del keyword for deletion of columns from a data frame. So let's get started. Let me just create a new notebook first and rename it. So let me just change the name to del keyword. So the topic for today is del keyword and its use for dropping the columns of a data frame. So del keyword can be used for removing a column. Earlier, I demonstrated the use of drop method for removal of a column. Now I'll teach you how to remove a column using the del keyword. So let me just import pandas as PD and let me just read a CSV file and extract the data frame from that particular file. So this is our data frame. Let me just create a new column real quick. So let's add a column. So df of blank is equal to none or anything. So it's giving an error because it can't be directly used. We have to write numpy.nan. I think so because it is in numpy and not in Python. NN is not a data type supported by Python. So let it be blank or white space or anything. And let me just display the data frames. Now I have a column with the blank values or empty values. Now let me just conventionally remove this column. So conventionally we used the drop method. So I'll write df.drop and I'll pass the column name. Axis is equal to 1. So this is the conventional method and it does not cause any change in the original dataset unless you specify in place as true. So no change in the original data frame until and unless we specify in place true. So it won't commit any changes until you specify in place as true. So I'll pass df.drop the column name, axis is equal to 1 and in place is equal to true. So now it has been removed. Now let's see how to use the del keyword to achieve the same result. So let me just add the column once again. So df of blank is equal to none this time and display the data set. So this is the extra column with none values. Now I'll just simply write del df and the column name in square bracket, and it has been deleted from the original dataset as well. We don't need to specify in place true or something like that. So deleted successfully without passing additional parameters like axis or specifying the in place as true. So in today's lecture, we covered the use of del keyword for removing columns from a data frame. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, we'll learn how to deal with not a number or none values in a data set. We have already discussed some of it in the data cleaning portion of this playlist, but we'll cover this topic in a finer detail today. So let's get started. So our topic is dealing with NaN values in a data set. So that's the topic for today. So first job is always to create or import a dataset. We'll create a dataset instead of importing it. Let the data frame name be df1 in this case, and we'll pass a dictionary here to create a data frame. So let me just do it quickly. So it has two columns, that is A and B. The elements of column A are gonna be A0, A1 and A2, while the elements of column B are gonna be B0, B1 and B2. So B0, B1 and B2. And our index gonna be 0, 1 and 2. So I have to pass the index. The index is equal to list 0, 1, 2. Now I'm gonna run this thing. There's an error. I forgot to import. Let's import. So import pandas as pd and df1 is equal to pd dot data frame. So this is our first data frame. Now similarly create a second data frame. Just change some of the values. So second data frame can be created in a similar manner by changing a few values. What we are actually gonna do is we are creating two data frames and we are gonna concatenate it along the axis 1 so that we have some of the values as NaN. That's how we are gonna achieve some NaN values. We can also directly insert some of the NaN values using numpy.nan, but here to make it a little more complex, I'm using concatenation. So I've concatenated both the data sets or the data frames along the axis 1. So now I have 1, 2, 3, 4, 5, 6, 6 into 2, 12, 12 NaN values. Now our first job is to check for null values or NaN values in this case. So checking for null values. So we can check for null values by isNull method or function. So I'll write q.isNull and all the null values will return true while other values will return false. So we'll get a sort of data frame as a result, and the entries corresponding to the null values will be true and corresponding to not null values will be false. Now we can see how to drop all the rows with null values. So I had already discussed this. Just write me q dot drop na. So all the rows have been deleted because all the rows contain null value. So drop na removes the rows with null values. This we have already discussed in data cleaning, but I thought it would be great if I explain it in detail here. So by default, drop na or drop null is false in place. So it won't cause any change in the original data set unless you specify in place is equal to true. Now we are gonna fill the null values. So for that we have fill na method, and I'm gonna pass whatever number or string I want null values to be replaced with. Now all the null values will be replaced with the string fill. So here we can see the result. Now moving on. So if we want to assign NaN value to some variable directly, we can't do it using the Python functions or the Python concepts. We have to go for numpy. So I'm gonna import numpy as np, and I'm gonna write q of new is equal to np.nan. This is how we assign NaN value to a row or a column. You can't directly write q new is equal to NaN. It won't work. So now you know how to directly assign a row with NaN value. So in today's lecture, we covered how to deal with null or NaN values in a data frame. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. In today's lecture, I'm going to teach you about pivot tables. So let's get started. So what is a pivot table? So pivot table is nothing but a multi-index table. So earlier we had just only one index or label. Here we can have multiple and we can sort them. So we are basically trying to create a multi-index table from a normal data frame. This is what we are gonna do in this video. So pivot table simplifies the presentation of data in a data frame where we have table redundant a pivot value for a particular. So let me just import pandas set of as PD. So let's now I'm going to first create a dictionary or a normal data frame in order to and then we'll create a pivot frame. So let the dictionary be A, B, C and D respectively. So A and B have redundant. So A and B will act as the multiple indexes. So let the elements of A be 4 bar redundant and the elements be 1 and 2 for the column B also redundant. So we have created a dictionary. Now let's create a data frame. So df is equal to pd.data frame and I'll pass the dictionary. So this is the resultant data frame. Now I have to create a pivot table. So let's create a pivot table. So in order to create a pivot table, I have to write df.pivot table with then underscore separation and I'll pass values is equal to D because it represents the data. Index or the multi-index is represented by A and B and let's represent the columns by C. So the columns is equal to C. So the columns are X and Y. Now this is the resultant data frame or pivot table or a pivot data frame. So in today's lecture, I covered how to create a pivot table from a normal data frame. Hence, we have created a pivot table successfully. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates and stay tuned with us for next lecture. Thank you. Hi guys, welcome back to our course on pandas. This is gonna be the last theory lecture. I'm gonna teach you how to read data from HTML files. So let's get started. So today's topic is reading data from HTML files. So we have to install HTML lib, LXML and beautiful soup before we can actually read data from HTML files. So these are the commands for installation, that is conda install lxml, conda install html5 or html5 lib, and conda install beautiful soup 4. So I have installed. So after installation, you have to restart. So restart notebook. So just close it. Close your browser. Open the Anaconda Navigator again and launch the notebook again. So I have launched the notebook successfully. Now I just need to look for that particular file. So it's in desktop. So I'll just go to the file was reading html.ipynb. Now I just need to import pandas as pd. So import pandas as pd, and then I just need to write df is equal to pd dot read html. It's similar to reading from CSV or JSON. I just need to change read underscore html, and I have to pass the link of the file.